Hey there, data enthusiasts. If you're tuning in, then you're probably someone who appreciates the intricate dance between data architecture and athletic performance. And this is a small subset of people. I recognize this. This is for my sports scientists. This is for my data people. So it's not going to capture the wide audience of just us strength coaches. But today, we're going to unpack some of the small nuances of data lakes, data warehouses, and data lakehouses, especially in the context of athlete management systems, or AMSs. We're also going to explore how commercial platforms like Smartabase, Kitman Labs, Edge 10, Apollo fit into sort of this landscape. So let's get started. Now, understanding the foundations of what these things are is really important. So let's begin by clarifying what I mean by data lakes, data warehouses, and data lakehouses. Now, a data lake is a central repository that allows you to store all of your structured and unstructured data at any scale. Now, you can store it as data, as is, without having to first structure the data and run different types of analytics on it, from dashboards to visualizations to big data processing, real-time analytics. And you can leverage machine learning to actually guide better decisions with that. Now, on the other hand, a data warehouse is a system used for reporting and data analysis. And it's considered a core component of a lot of business intelligence suites and softwares. Data warehouses are central repositories for integrated data, right? And they store current and historical data in one single place, which is used for a lot of the data analytical work and reports for workers throughout the enterprise or sporting organization. Now, a data lakehouse is a relatively new data management architecture, and it sort of combines the benefits of data lakehouses and data warehouses. So it merges the flexibility and cost efficiency and scale of data lakes within the data management and sort of structure of these databases, right? Now, in addition to sort of that conversation surrounding those things, understanding that the foundational concepts is really crucial as we sort of delve deeper into how these actually apply to athlete management systems. So that said, let's get into talking about AMSs and sort of what those data needs are for a particular AMS and why a sporting organization might use one versus another. So if you're unfamiliar what an AMS does, athlete management systems are designed to collect, store, and analyze data related to athletic performance, maybe health, wellness, and sometimes they involve actually an electronic medical record system as well, an EMR. And these systems need to handle a variety of different data types. And that's really important when you're starting to look at what data structure or schema one might use. So that said, there's structured data, and this might look like things such as maybe player statistics or game scores, or maybe even biometric readings. There's also unstructured data, and that includes video footage, it might be medical imaging like MRI and X-rays, and it also might include like social media content if you're trying to tie in different engagement and things like that. There are things called semi-structured data, and this might be like JSON files from wearable devices like Catapult Sports or Kinexon. There's XML files from scheduling software and different sort of video analysis softwares that are commercially available as well. So given this diversity, the choice of data architecture becomes really critical. And I think it's important that you consider the architectural sort of styles in which these databases bring and how they actually handle various different data types. So with a data lake, those are sort of ideal for storing vast amounts of raw data in a native format. Think of like a gigantic lake that you just dump data into, right? They're highly scalable, and sometimes they can handle both structured and semi-structured and unstructured data all together. You just kind of throw it into the lake. However, there's the failure of those is that sometimes they lack the robust data management features that you would expect with a data warehouse. Now, data warehouses, on the other hand, are very excellent for handling structured data, and they support complex queries and analytics. They enforce data quality and consistency, but the downside is sometimes they're less flexible in handling unstructured data types like video. And that's kind of where data lakehouses, this new sort of term, comes in. They offer a unified platform that supports all data types, and they provide the data management features that you would expect with a data warehouse. They are becoming increasingly popular in scenarios where the data is quite diverse, but also needs to be analyzed in conjunction together. So in the context of an athlete management system where data varies quite consistently and the volume of data is crazy high, data lakehouses are becoming the architecture of choice for a lot of these sporting organizations as they start to look at their data needs and the demands of what their data is asking of the sport organization. So I think it's important that we examine maybe some commercial athlete management systems and how they align with these architectural sort of subsets, if you will, right? Now, this is just a small population sample of the AMSs that exist in the commercial space, right? So by no means is this a comprehensive list of every commercially available athlete management system that exists in the market, right? So one of which is Smartabase, right? Now Teamworks AMS. And it's a comprehensive AMS system that integrates various data sources, including performance, metrics, medical records, wellness questionnaires, and so much more, right? That specific architectural detail is somewhat proprietary, and it's reasonable to infer that Smartabase utilizes perhaps a data lakehouse approach to managing the diverse data needs that they have, the data types that they bring in, because they do provide real-time analytics to their system. There's another commercially available system, Kitman Labs, which was probably known for its sort of injury prevention or mitigation strategies and the performance optimization. Now, Kitman also employs a data lakehouse architecture, and this allows for the integration of structured data like training load data and catapult and various different wearable technologies, but also unstructured data such as video analysis and video imaging like MRIs and attachments of x-rays and things like that, to provide maybe a holistic insight to things. There's also Edge 10, right, which also offers customizable solutions for athlete monitoring. And given its emphasis on the flexibility and scalability, a data lakehouse architecture would also support its needs to handle that various data types, providing both tailored analytics, but also a warehouse to sort of store unstructured data as well. The last sort of AMS I'm just going to briefly mention is Apollo. And Apollo also focuses on streamlining data collection and analysis for sport organizations. So if you were to guess, again, probably a lakehouse architecture would facilitate the integration of different data sources and also support the advanced analytics capabilities necessary to really leverage that data in real time. Now, these platforms demonstrate how the data lakehouse architecture is well suited, right, for the complex data needs of athlete management systems, right? No longer is it just acceptable to have a data warehouse or a data lake. You actually need to be able to store multiple different various types of data, but also leverage the analytical tools to be able to make sort of better decision making off of that data as well and queries to it. And this is where organizations often face the decision between building a custom AMS or purchasing a commercial solution. So I think it'd be fun to kind of jump into maybe the pros and cons. So building a custom AMS, right? The magic holy grail of things, right? Now, some of the pros might be that it's tailored to your organization needs, right? You might have greater control over the data and features, and you might actually, have potential for a competitive advantage through proprietary analytics. The cons, though, it is highly developmental and maintenance heavy costs, right? Requires specialized sort of technical expertise. Your average strength coach or probably even graduate from a data science program is not going to be able to do that. And it takes oftentimes longer times to deploy and iterate new features. So when looking at purchasing maybe a commercial AMS, right, the pros would be you have a faster deployment with proven solutions. You have ongoing support and updates and iterations. You have access to industry best practices when it comes to data management and data security. But the cons are, as you could imagine, there's less customization. There's more potential data integration challenges through APIs and struggling integrations like that. And there's also ongoing licensing costs. And those licensing costs and those fees can be astronomical. So the choice between really depends on your budget, your technical capability, and the specific organizational needs. So whether one is right or wrong is really up to your own organization. And for those interested in the technical aspects of AMSs and data lakehouses and warehouses and etc., let's kind of dive into that for a moment, because I think that might be interesting as well. Because data lakes are often built on platforms that utilize cloud storage services. So think of your Amazon S3s, your Azure, your blob storages. They all use schema-on-read, allowing for flexibility in data ingestion, right? Your data warehouses often, which tends to be a little bit more structured data, often use languages like SQL and are optimized for read-heavy operations because they enforce sort of schema-on-write, ensuring data consistency, right? Now, your data lakehouse oftentimes combines the flexibility of both a data lakehouse or data lake with the data management features of data warehouses. So that might include technologies like Delta Lake and Apache Iceberg, and all of that allows and enable transactions and support for structured and unstructured data. So in terms of programming languages, what might one do or what might one need from an expertise level? And that's where programming languages like Python and R are commonly used for data analysis, where SQL remains essential for querying structured data. So tools like Apache Spark facilitate large-scale data processing, and machine learning frameworks, things like TensorFlow or PyTorch, are employed in actually leveraging predictive analytics. And understanding these technical components is vital for implementing effective data architecture in AMS systems, right? You can't just go into it blind. You actually have to understand how data is managed and built and the architecture and the schema of the systems. So in summary, the choice of data architecture, be it a data lake, a data warehouse, or a data lakehouse, has significant implications on athlete management systems. As the volume and variety of data continues to grow, data lakehouses offer a compelling solution by combining flexibility with robust data management. So whether you're considering building a custom AMS or selecting a commercial platform, understanding these architectures will guide you in the decision-making whether you're considering building a custom AMS or selecting a commercial platform, understanding these architectures will guide you in making informed decisions that enhance the athlete performance and organizational success. Thank you for joining me in this sort of nerdy deep dive. If you have questions or thoughts, feel free to share them in the comments below this video. And until next time, keep pushing the boundaries of data and athletic performance, because that is where the magic happens.